Welcome back, and we will continue with our course on electronic packaging and manufacturing. So, if you recall, in the last class we had talked about semiconductors. We have got introduced to the concept of a p-n junction followed by a diode, and then we also looked at some microfabrication techniques by which you can use to fabricate a diode. Okay. So, those microfabrication techniques that we saw are used to to have all these components etc. on a microchip. Okay. So, microchip, die, integrated circuit, these terms are going to be used interchangeably okay, throughout this course. So, please keep that in mind, and if at any point you have any confusion, these unless otherwise specified would mean more or less the same thing. Okay. So, with that, what we now do is we will come to first level packaging. Okay. So, that is the topic of today's course. So, that is what we are going to start with, and first level packaging is probably going to continue for a while, probably definitely for 1.5 weeks and maybe even 2 weeks. Okay. So, because this is probably the most important, where we are going to talk about how the signals from the integrated circuit is being carried out of that circuit through the motherboard into other components, so on and so forth, and what are the different designs and the different technologies that are used to have this what is called the I/O or input output or interconnections. Okay. So, first level packaging, what we are going to discuss today, we will just briefly discuss about the levels of packaging, if you recall what we had studied or what we had mentioned earlier, and then we will straight away go on to first level packaging. Okay. First level packaging, we will see is something called chip to chip carrier, and which immediately brings the question as to what is a chip carrier, and then what are the different types of chip carrier once we know what a chip carrier is. Okay. All right. So, levels of packaging, let us recall what we had discussed earlier, probably in the first lecture and the second lecture as well, in the introduction part. Level of packaging, the first level of packaging is when you get the silicon out from the wafer and connect it to the chip carrier, or connect it basically to its substrate and have these interconnections come out. That is first level of packaging. The second level of packaging involves the chip with the chip carrier and with these interconnections coming out of that, how is it put on a motherboard or a daughter card, and how the signals are now being conducted through the motherboard. Okay. And the third level is something that goes into from the motherboard to the overall system through connectors, assemblies and so on. Okay. So, first level again is where the starting point is the piece of silicon with all the circuitries inside, whether it is diodes, whether it is transistors and so on and so forth. Okay. So, recall, if we just go back yesterday to the sketch that we saw, okay, what did we have at the end? This was my N semiconductor, and then this was my P semiconductor. And what did we have? We had the we had these connections or the junction between the P and N. Okay. But then the question comes is, well, we now need to have this external source of voltage connected to this p-n junction. So, how am I going to do that, right? So, definitely, and from very simple point of view, I need something coming here and something being attached here, right. So, this will be the plus, this will be the minus, but it is not so simple. The point I am trying to make is, and let us say there are millions of these devices on a piece of silicon semiconductor chip, and so each of those would need these connections to come out and finally go to the the power supply that we have. Okay. So, that is where the first level of packaging comes in. How do I get these connections out? Okay. So, that is where the concept of what is a chip carrier also comes into picture. So, what is a chip carrier? The first question is, what is a chip carrier? The chip carrier is the housing for the thin and fragile chip. Again, the chip is this piece of silicon that I have diced or cut out from the wafer, which is circular in shape. Now, what is the purpose of the chip carrier? It protects the chip from the environment and abusive handling. So, I cannot be, first thing from reliability point of view, I cannot be carrying this very thin, fragile, delicate piece of silicon. So, I need to give it a protective housing, and the chip carrier does that. Okay. The second one is what we are talking about. It facilitates the interconnections from the chip to the pads or holes on the circuit board. I need to take this piece of silicon and put it on the circuit board. Now, how do I make these connections to the wiring traces that are there in your motherboard? Correct. So, that is where these interconnections become very important. Okay. The provides pins or pads that serve as bases for solder joints. So, this actually ties into the previous point. So, these are the way connections are made. We are going to see all these later. So, at this point, even if you do not understand, you can just assume that these pins or pads. So, many of these interconnections happen because of soldering, and the chip carrier is the basis that forms the pins or pads that serve or basically that facilitates these interconnections to happen. Okay. So, if I have to give you a very simple example, okay, a simple example, let us say, which is analogous to what I am talking about. If you take your simple plug point, okay, what does the plug point have? Whether depending on 2 pin or 3 pin, it has these 3 pins that come out, and then you have a socket on the wall where it goes in, right. So, that is how I am powering up my system. What happens? Inside the socket there are these metallized connections, and when these pins go in, they form an electrical joint. Okay. So, through these holes, through the pins or the holes, the pins when they go inside the hole, there is a metallized connection. Okay. So, similarly, that is one example that we see in everyday life. So, you can think of a similar arrangement for a chip carrier carrying the chip with these pins coming out, and on the motherboard there are corresponding holes into which it goes and plugs in, and that is where the connections are made. Okay. We will see all these later, okay. But this is pin in hole arrangement, that is what it is called, and it is very similar to what you have in the regular plug points that we see in our everyday life. Okay. So, the purpose is to provide those pins or pads that serve as the basis for solder joints, and solder joints basically are these connections. The last point, as you see in this slide, is that is very important, is it also provides a means for heat transfer. See, all this circuitry, when they are powered on, is going to generate heat. Why? Because of Joule heating, I squared R. Everything is the resistor, as current flows, there will be heat that is generated. Okay. And if this heat cannot be dissipated efficiently, the temperature of these circuits are going to rise and reach a threshold where it can just burn and it can lead to failure, temperature induced failures. So, therefore, the chip carrier also has this additional function of providing the first step in the heat flow path from the source, which is the source is the circuitry where it is generated, to the sink, which is where it is dissipated, whether it is air cooled, water cooled, whatever it is. Okay. So, the chip carrier has many functions, as we can see. All right. So, now let us look into a picture of a chip carrier. Okay. This is a very simple picture as we see here, but I can tell you that there are many different types of chip carriers that exist today, but more or less they all conform to this parent structure. So, let us first understand what the different parts of this diagram are. So, first what we have is this chip, okay. Then there is something called a case. Okay. So, what I am showing you over here is a cross section, all right. So, if I take a cross section, this is how it looks. The chip is a piece of silicon and there is a lot of circuitry over here. If I want to draw this, okay. So, there is going to be circuitry over here, sorry. There is going to be some circuitry over here, some circuitry over here and many more. Okay. So, these are the points from where I have to take connections out, all right. So, how is that going to be done? As you can see, there are these wires that are connecting, that are basically joined or that are basically joined to these points. Okay. So, these are called the bonding wires. Okay. Now, what happens if you look at this, these bonding wires finally are connected to another metallized structure which are known as leads or pins. Okay. And these leads, by the way, you are seeing only two of them, and if you consider several of them in the third direction, in the depth of the in the direction of the depth of this screen, then they are all part of something called a lead frame, which you cannot see over here, but what you can see, that just the cross section part is over here. This is my lead frame. Okay. And then this whole thing is encapsulated inside a case which can be made of ceramic, which can be made of plastic and sometimes some other exotic materials as well. Okay. So, this is a configuration of a chip inside a chip carrier, okay. And then this whole thing has a cover or a lid. Okay. So, keep in mind there are two very similar sounding words. One is called a lid, LID, the other is called a lead, which is LEAD. Okay. The lead is the one which connects to, which forms the connections, and the lid is definitely a cover, all right. And then the chip is connected to the lead frame by some kind of an adhesive, which is and that is the bonding structure, there is a bonding material, all right. So, then what am I seeing over here? I had some points on the piece of silicon, and then once this piece of silicon or the chip is connected to the chip carrier, what are the connections now? The connections are in the form of these pins. Okay. If I now draw something, sorry. So, what I will be able to see is, if I look at it from outside, this is how it is going to be. I cannot see because this is the case and the lid. So, what is inside? Somewhere inside probably the silicon is sitting over here. Okay. But then what I see over here are these leads that are coming out. Okay. And so, these are the ones that now form this or enable me to do these connections to the motherboard. Clear? So, I am sorry for the quality of drawing, it is not very nice, but I hope you get an idea. If you just repeat it from outside, now once it is covered, I am unable to see this chip and these wire bonds inside. I cannot see this chip and the wire bonds inside, but what I am going to see is this outside cover and these leads coming out. Okay. So, as I said, there are many different kinds of structures of chip carriers that exist today, but they all more or less conform to this parent structure. Okay. Now, the next thing that I am going to talk about is something called a Rendt's rule. Okay. That determines that how many of these leads or pins do I need from a certain piece of silicon. Okay. So, need for the pin outs is defined by Rendt's rule. Okay. So, the number of these interconnects or IOs is given in this form: A times Ng times A times Ng to the power B. Okay. What is Ng? Ng is the number of gates or terminals inside your silicon. Okay. And IO is the number of these pins or terminals or these interconnects that we need. All right. So, what you can see is, if you look at over here in this picture, what you see is there is the number of terminals for a same number of circuits or bits depends on the type of the microprocessor that you are using. Okay. But this is how it is shown, and the point I am trying to make is the number of terminals that come out of the chip carrier is not equal to, is not necessarily equal to the number of gates or circuits or that is there inside your chip. Rather, it is much lesser. If you look at it, if the number of gates is like 1000, depending on the type of microprocessor we are talking about, it can be as low as 10 to about 30 or 40 to about 100. Okay. So, orders of magnitude less. So, again let me try to give you an analogy, same analogy of the plug point. If you take your computer, desktop or even a server, laptop or any other thing, TV, microwave, there is a lot of intense circuitry inside. But finally, what is the final number of interconnections that we are getting? Number of pins that is coming out? It is either 2 or 3. If it is 3, one of them is ground, and that is what is finally going into the wall socket. So, you are powering up your computer, the number of input output that finally comes out of the system is just 3. And then once it goes inside the system, it fans out, etc., and it grows in number, probably going to your microprocessor, which has probably 1,000,000 circuits inside. Okay. So, this is just to give you an analogy that finally just 2 points is powering up everything, all the complex circuitry inside your computing product. Okay. So, if you scale it down and just concentrate on the microprocessor, then the piece of silicon has millions of circuits, but what comes out probably are a few thousands. Okay. So, the number of interconnections that is coming out of your microprocessor is probably definitely orders of magnitude less compared to the number of circuitry or the number of transistors that you have inside your piece of silicon. Okay. So, that is what Rendt's rule gives us. Okay. It is A n to the power b, and if you look at some of these examples for memory, low end memory chips, the power b is 0.12, whereas high end mainframe computer logic circuits, the b is 0.63. So, that kinds of gives you the feel. Okay. It is never to the power 1. Okay. All right. So, now that we know what is a chip carrier and what it is supposed to do, what are the key design features of a chip carrier in that case? Okay. The first is the IO count. See, the modern VLSI chips have thousands of gates, thereby requiring large number of IOs. Not just thousands, I would say today there is millions of gates. So, there is large number of IOs, probably sometimes ordering to thousands. Okay. So, the chip carrier should have that kind of capability to be able to accommodate this high number of interconnections. Okay. The second one is hermeticity, sealing it, protecting it from outside factors, moisture, it is a killer. Okay. That is why we have, if you are talking about circuit or devices that are operating in hot and harsh environments. So, packaging for that is very essential. Moisture is a very big enemy of electronic circuits. So, it has to be sealed and protected from these kinds of extraneous or environmental factors to ensure reliable operations. Okay? To ensure that moisture does not get in, it does not get in to corrode the pins, wires, your circuit will be gone. Okay. Just to give you an example, I mean again from real life, my very recent personal example, my washing machine. For a long time, my washing machine was stationed outside in the backyard of my house. It was covered and all that. But what happens is, especially during the rainy season, now that it is October now over here, we are just coming to the end of the we have just come to the end of the rainy season, and suddenly, actually it was giving indications. Suddenly one day we would see that if you power on the body switch, it is not powering on, and then after a few attempts it will be powering on. Okay. And slowly that became worse, and finally one day it stopped working, and the whole idea was moisture content. Sometimes we also saw that on one day it did not power on, the next day it did not rain, it was sunny, the whole day was more or less dry, and then it was powering up. Okay. But slowly what happened was, with time it degraded further and further, and finally it stopped working. Okay. We brought it indoors, etc., but by that time the damage was already done, and just as of today morning I had to get that small circuit card replaced. It cost me a few thousand rupees, definitely much lesser than much cheaper than buying a whole new washing machine, but the main culprit that led to this failure was moisture, and I am responsible for that, because unknowingly or knowingly, well, I should have known better, I had subjected this whole equipment to a moist environment, to a level of moisture which it was not designed to handle. Okay. All right. So, that was from my personal experience as current as today morning. The Samsung guy came and he replaced that small motherboard that is over there in the circuit that is inside your washing machine. Okay. What is the third one? The hermeticity, the organic materials that release volatiles with time are not used. Okay. So, we do not use materials in chip carriers that are made of organic materials that can be I mean we do not use such organic materials in our chip carrier that can outgas and release volatiles with time, because these are also going to lead to degradation of this circuitry inside. Look, I mean especially the picture that we saw before, we are talking about very thin, fragile, delicate wire bonds. Okay. And the final part is heat dissipation. So, now if I go back to the previous this picture, you see this chip is going to generate heat. How can I dissipate that? The main path for heat transfer is going to be through the bottom. It is going to go through this bond to the lead frame and then to this casing, and sometimes through these pins as well, and that is how it is going to be conducted away. Sometimes this portion inside, which I am showing as hollow, is also completely encapsulated by a plastic, let us say, or an epoxy, and that also helps in some conduction of heat from the chip in the upward direction. Okay. So, heat dissipation is important, and the chip carrier, that is one of the functions of the chip carrier. And when you look at, when you are trying to design a chip carrier, these are all the things that need to be taken into account. Okay. So, let us now go into the types of chip carriers. What are the different types of chip carriers? Now, types of chip carriers can be classified based on several parameters. Okay. I mean there are several types of classifications. Based on materials, the chip carrier can be plastic. If it is a plastic chip carrier, then we call it, we will look into all those. Okay. The next one is, it can be made of ceramic, The third one is a tape type of chip carrier. We will briefly touch upon that. That is based on the type of material that is being used. Based on connections, how are these connections? Okay. Are these pins that go into holes, then that is through holes, then there is something called surface mount, and there are also something called leadless. Sorry. So, there are no leads, there are some kind of a direct contact. We will see all these. So, based on connections also there are some types of classifications. And finally, based on the layout of the interconnects, is it peripheral, is it area array, is it flip chip? We will see all these, what all these mean. Okay. So, these are the different types of chip, the classifications of chip carriers depending on the parameters that we choose, whether it is material, whether it is type of connection, or whether it is the layout. Okay. So, that brings us to the end of this lecture, and what we will do is in the next lecture we are going to pick up from here and talk about both ceramic and plastic chip carriers. Okay. Thank you very much.